Okay, we're live on YouTube. All right, everybody got the data sets here. There's a copy of it in the chat panel. Open it. There's a bunch of geometry that we built in the last class on the right side. These were all leftovers from an explanation on how you create and what are the different properties of walls. We're going to delete them. I'm going to show you quick ways or quick shortcuts to delete things in Revit. If you want to delete elements of the same type, you can use the right-click menu to select things by type across all the across all the model. So you select, for example, one partition, and then you right-click, and there's this right-click shortcut, select all instances in the entire project. And so that select all the elements that are exactly the same type. And then you hit the delete key. Easy. Or you can just, Windows select and hit the delete key. Just make sure you don't select anything else. Don't pick the levels, which are important, and don't pick the floor as well. Okay, and so we wanted to create a custom partition from scratch. And so there are multiple ways to create a new partition from scratch. I think the one I'm going to use for us to apply in this project, it's using the project browser. So look at the project browser and open the family tree, the families. This is the list of all the loadable components and system families available for you to use inside a project. What we're going to do is going to use a placeholder to create a new wall type. So open the walls, open basic wall, and open the generic, select the generic 8 inches. And so to create a new type from an existing one, I'm just going to write a quick rule here. I think we've done it in the past, but I'm going to write it again. Create new types. Step number 1 is duplicate a type. Step number 2, rename it. It's important to rename it according your project standards. Sometimes, in particular, when it comes to walls, there's a lot of particular ways on naming wall types, and they usually follow nomenclature that is aligned with the way a partition is set up. And then the third time is change parameters. And you can create new types by selecting a wall on the project, or you can create a new type by selecting it on the project browser. So 2 different ways of doing the same thing. So I'm going to create a new partition based on the generic 8 inches that's available to me in the project browser. So select the generic 8 inches, right click. Step number 1, we duplicate it. When we duplicate it, Revit adds the name or the suffix to next to it. Notice that there is a generic 8 inch in brackets. Ignore that one. When you duplicate it, the suffix to is added at the end of a copy. So I'm going to rename it, and I'm going to call this exterior dash Mila house. There are different, like I said, there's different ways of naming partitions. This is very descriptive, but if we're doing this in the context of architectural production, make sure that you pick a name that's aligned with your internal standards. All right. And then the step number 3 is to change parameter values. And to access the parameter values of this new partition, just double click the type. And this is going to open the partitions dialog box. Here it is. You guys with me? Fairly simple. You just right click on the partition, the project browser, the generic 8 inches, duplicate it, and then rename it. These are the type properties. And remember, type properties are the properties that are common across all the elements in the project. So this is properties common to all type. And what that means, if I change a property here, it's going to change it across the entire project. So be very careful about when we edit type properties, because very often, and it is a common Revit mistake, is that we try to create a new partition, but we didn't duplicate it. And if we don't duplicate a type, we're gonna change existing partitions in the model, and we're gonna change geometrically and impact the modeling. And so let's be careful about when we actually duplicate a type before accessing the type properties.
Isn't this true to pretty much any type of duplication of or recreating of an element from another element? You want to duplicate it, rename the type to make it unique, and then you're free to edit it.
You hit it right. Like, this is not true. This is true not only for the walls, but this is true for every family available in the project browser. If you want to customize a new or create a new type based on an existing one, always rename it. And this is true for furniture, for walls, for ceilings, for roofs, etc. But more importantly, also, it's name it in a way that is consistent, so that your users or the users that are participating in the model know what it is. You know, like sometimes we create family types where we leave it very generic, or we actually don't name it at all. And so it makes sense for you who created it, but what about the rest of the team? And so the rest of the team needs to be able to understand that this is a family, that it's part of a collection of objects that are shared and that follow naming standards, and that it can be reusable. And then the opposite also as well happens. You know, if I am the BIM manager and I see redundant families that don't mean anything for anybody else, I'm going to select those redundant families and delete it. For example, these generic 8 inches in bracket 2, I would question what that is. And you can actually see the usage of a family. And if you select a family in the project browser and you say select everything in the project, the filter in the lower right side is going to list all the elements in the project that are part of that type. And so you may, if this is not in use and is redundant and it doesn't make any sense, you can delete it, right? But thanks for the comment. That's true for every family in the project. All right, so we have the Miller House partition duplicate open. I open the type properties. Open the preview. The preview is, it's a panel that displays a section in plan about a model. And notice that there's already some changes here. There's some I think in last class when we were doing this, we modify, or I modify the generic 8 inches, and that was my mistake. So that means that the generic 8 inch is no longer what it used to be, which was just a single layer of generic material. But we're gonna pick it from here. We're gonna edit the structure, edit the button here. The preview panel, it's a geometrical display of the partitioning plan, but you can also display it in section. So in the lower right side of this panel, you can flip between a floor plan representation or a section plan representation. And sometimes this is useful, depending on what you're doing, to understand the graphical structure of this tabular display in a format that you can consume visually. And so notice that when you click on a layer here, the layer in section get highlighted. And so you can actually correlate the components of the assemble with this section, with the visual section. What I said last time is that like layer number 2 and 4, which are called out as core, those are not actually materials, those are delimiters. And so the layers in between the core are the ones that are used for the structural analysis. And are the layers that transfer the weight of the structure. And when we also place walls and we pick the core boundary as the placement plane, the core, this layer is what acts as the interior or the exterior core location line in wall types. We were talking about location lines last class. Okay, so in my new partition, we are going to build a wall that has a finish that represents a material called wood vertical, and that is 1.5 inches. Yes, that works. Then we're going to have a structural core that's going to be made of wood, of a wood structure. So when you pick on the material, you can swap it by clicking those 3 little dots. That 3 little dot icon open the material library. And in here you have a list of materials provided by the project template. And I talked a little bit about materials last time. You can search materials by keyword. The keyword search is associated with the name. And just type for wood. Let's see what's there. Or I think there's a stud layer. So it's not wood, but stud. Oh, there's only metal stud layer. Okay, so this is an example where a material is not available to me. I'm looking for a wood stud layer, and the only thing I can find is a metal stud layer. But I can create new materials based on existing ones. So let me show you how we do that. And the process is very similar to the way we created the new types. We pick an existing material as a placeholder. We duplicate it. And in the process of duplicating, we also duplicate some of the assets. The assets are the graphical and metadata representation of a material. There are graphical assets, appearance assets, physical assets, and thermal assets. And all these are collections of properties that define what a material is. And so if I'm looking for, or if I don't have a wood stud layer available to me, I can duplicate it. So again, if you're not seeing what I have on the screen, this is how I got here. I duplicated the partition, rename it as Mila House, then double click, and then open the structure button. And I am in the structure core under the material column that says by category. When a material says by category, that means it's defined by the default value in object styles. I think last class I talked to you what object styles was, is a global setting of materials in Revit. And most of the time, most 80 to 90%, we don't define materials per category because the rule is too stringent. I mean, Imagine every structural framing has a single material. That's not realistic in any project. And so for the most part, the materials are not part of those. The materials remain empty. The material and the object styles remain empty. But by category means that it's going to read the global setting. Now, I'm going to duplicate and create a new material. So I click on this three little dot button next to the material cell. I'm going to search for the stud, a material called stud, which narrows the result to a single material called metal stud. And please don't hit the cancel button here, because if you cancel, you have to start over, and this is a multi-step operation. You're gonna fall behind. So you select the metal stud layer material, right click, and starting in Revit 2023, you have now the ability to duplicate material and assets and duplicate using share assets. And what does that mean? I told you that Revit has appearance, physical, and thermal assets. And sometimes those assets are used across multiple projects. For example, concrete. You can have like 5 different types of appearances associated with concrete, but they all share the same physical assets and the same thermal assets. Maybe the difference is the color. And so when we duplicate a material, we can create a complete set of copies of those assets, or we can continue using the share assets. It's up to you. I think assets can be duplicated as needed. Let me show you. I want to hit escape here just to show you what an asset look like. Like this metal stud layer is made of a visual asset called plate. And these assets, notice that there's like a little hand with with number 2. And what that means that is this visual asset is shared by another couple of materials. So this rendering, this image, all the properties associated with this rendering assets, it's also in use by a couple of other materials. I don't know what those materials are, but there are a couple of them that are in use. When you click on the physical materials, notice that there's an asset called steel 2 that is also shared by 2 other materials. And then there's a thermal asset called air, which is also shared by 3 other materials. And so the collection of these 3 different type of assets make this material unique. And when we duplicate a material, we can duplicate the assets as well. Okay, so I'm just gonna keep it simple, and I'm gonna duplicate using share assets. And then I'm gonna rename this. I'm gonna call this wood stud layer. Now, for all purposes, the wood stud layer and metal stud layer are exactly the same material at this moment. But then I can start making changes in the graphic appearance and physical properties.
So, Peter, can I interrupt?
Yes.
I didn't quite understand what the difference between duplicate material and assets and duplicate shared assets. I didn't catch on.
Okay. Yeah.
Sorry, could you just, I don't mean to hold. If
No, that's fine.
I can ask you later, but.
No, that's fine, totally fine. So a material, maybe I'll graphic this here. We have a material, and a material is a collection of graphic assets. And this is like the textures and all the properties that are associated with that.
Yeah.
You have physical assets and thermal assets that define the physical properties and the thermal properties of a material. And each of them, think of these as individual files that are all
Mhm.
part of the same material.
Okay.
So when we duplicate a material, we can maintain these assets as is, or we can create new assets, or we can duplicate each of them individually. So
Oh, okay.
when you right click and I pick duplicate using share assets, each of these assets is going to be duplicated. The plate asset, which is on the appearance, the physical asset is going to be like still 3 because you duplicate the assets, and the
Mhm.
Telma asset is also going to be duplicated.
Okay.
So right now I use duplicate using share assets, and what that means that I did not created brand new or copies of all these different assets. I'm going to replace that in the next step.
Okay.
That's the that is the purpose behind it.
Oh, okay. Okay. Sorry. Yeah, I understood it now.
Okay.
I have a
Thank
question
you.
as well.
Yeah.
So when you do that step, so the top right of your screen where you have the paper that's overlapping, you still want to duplicate with the selection you just made to duplicate all the assets so you can change them individually because they're still tied to everything else in the project, correct?
Yeah. And if you notice, I used to have the icon with the little 2. Now it's changed to 3 because the plate is now in use by 3 materials, including the wood still layer. And so the assets is used by 3 materials. And then here, I have a way to replace this asset with a new one. And then I have the ability to replace it with or duplicate it. And what I'm going to do is to replace this asset with another asset, the next step. Does that make sense?
Yes, it does.
Yeah. Okay. So when building a material, you need to be aware of how it's going to look, how it's going to perform physically, and how it's going to perform thermally. And how it's going to look in the documentation documents. Those are the graphic ones. All right, so I want to replace these assets. I need to pull a source of asset library materials. And the icon, the third icon from the lower left, this guy right here, it looks like a dialog box. This is the library of share assets of Autodesk products. And I mentioned the last time that this asset library is used by AutoCAD, Inventor, and all the family of Autodesk products. And it enables the products to maintain the materials when they are exported across. And so I am looking for some kind of wood. And here you have the appearance library, the physical, structural assets, and the physical assets. And on the appearance library, I'm going to open it. When you click the library, notice that there's a lock. It means that it's read-only. And these are the different classes. And classes, material classes it's a way to classify or structure a classification of materials based on the individual properties. For example, ceramic has different properties from fabric. And so the list of parameters is different from one class to another. So a classes define a collection of properties that are unique to a material type. When we create a new project from a new material from scratch, we are actually also picking what class of properties that material has. And so we want some wood. And when you click wood, you have all properties on wood.
Sorry, can you tell me again how you got to the appearance library?
It's this button right here.
Okay, I picked the wrong buttons.
Are you in the material browser? Was that Ruth?
Yeah, I got it. I just,
Okay.
I pushed the button.
Okay. Okay, so I open the wood class under the appearance library. Open the appearance library, hit the wood. And these are all the different type of, and notice that this is the asset type. You see this aspect, it says appearance. What it means is that these assets can only be used by the appearance tab. And so we pick the kind of stud material that we want to use. Maybe we use some pine. And so if you scroll down, you're going to find pine. And we can use a generic one because this doesn't need to be high photorealistic. And when you select the asset, you're going to notice that at the far right end of this row, there is an icon that's a double arrow. That means transfer and replace the asset into the appearance tab. So, or you can just double click it. And notice now in the appearance tab, I actually replaced the asset with a new asset. And there is not shared, it's unique. So now my wood stud layer has a unique appearance display of pine. And then the same should be true for the physical, and the thermal is not so critical right now because these are only important if we're going to do some energy analysis or we're going to send this over to a mechanical engineer. But let's do it anyway. I mean, this got to be a physical wood asset. So again, I'm going to open the asset browser and look for physical structural in the US. And there should be something called wood here. Maybe not. Let's open the physical assets. The first, yeah, it's the first folder. And then you go into wood, hardwood. Wait, pine is not a hardwood, right? It's a softwood. And here are all the different pines. Southern pine, Scott pine, radiata. Now, these assets only have information about how the material performs structurally. So you're not going to get any visual or appearance information. I'm just going to pick the pine southern. And when I double click, this material is transferred into the physical tab, and it inherits the thermal and mechanical and strength materials. And I think the same is true, should be true for the thermal. If you click the thermal, this is the thermal properties of the wood, and it should be exactly the same as the physical. So I'll do the same. You open the wood. I want to pick the same pine southern. And so if you compare the data, the first one, it's the physical one, it's focused on describing the thermal coefficient expansions and mechanical strength. And if you're studying for the ARE, you should know what all of this means and then memorize it and never use it again. And then the thermal expansion is focused on specific heat, density, emissivity, compressibility. I forgot what all this is about. I know that thermal conductivity and specific heat has to do with R values, the calculation of R values. Anyway, but this is the way you build a material. You select, you duplicate a placeholder, and then you select the individual assets that are important for the representation of the material.
I have another question.
Yeah.
So depending on if you're working with consultants use Revit and are going to use it for kind of energy kind of calculations or structural calculations, then you can gauge how deep you want to go into in terms of the types of assets or qualities that you put into the materials that you create, correct?
That's right. In fact, if you're not sure what physical properties needs to be, because that's the responsibility of a consultant, you may decide, I really don't need this asset at all. Like, it's not my job to decide what the thermal properties needs to be. So I'm going to remove it. And you see it remove the entire tab altogether. Because it's not relevant for the scope of work you're going to do. And so when the consultant, if a consultant is using Revit to do this type of analysis and is going to recycle your entities, then they could manage and add those assets as needed. If I want to add again, you just click this plus sign and say, okay, I'm going to add this thermal layer and pick it again. Does that make sense?
Yeah, that's
it
good to
does.
know.
Okay. Yep. Okay, here I changed the thermal assets, but I don't need to define it for my scope of work. Okay, so the appearance, for all purposes, the appearance is probably the most important one because this is how this layer is going to render. And the other thing we must not forget is to give the appropriate graphic and identity information. Like if you click the identity data, use this is a description that you typed, and this is no longer a light gauge steel framing. This is light wood framing. And then the other thing important is to make sure that we classify the material correctly. This class is not metal, but it's wood. And then when we do schedules, or in particular, if you're an interior designer and you're doing interior elevations and you want to like call out the different finishes of a wall, for example, you may want to use material keynotes. And in that, for example, you can say, okay, this is going to be a pine finish that I'm going to call wood 1. And it's part of a keynote that is interior wood panel or something like that. And so these way of adding metadata to the material help us create these interior elevations with interior elevation marks. And we place material keynotes. We're going to talk about that later when we talk about documentation. And then the graphics. The graphic is how the material is going to render how the material is going to be displayed in shading mode, and how the material is going to be displayed in the documentation, in the construction documentation. So in shading, you usually click this use render appearance. And what this does, it reads the JPEG image. You grab this closest RGB color and insert it here. And so what does that mean? When you switch the 3D view to shading, then it's going to look like that. If you don't use the shading appearance, then it's going to have this gray color. I usually like the shading to match the rendering color. And then on patterns, I need to talk about two types of patterns. You have the surface pattern, which is how a material is going to be displayed in projection, like a floor plan, typical like a vinyl floor that it's in a floor plan, that is a surface pattern. And in Revit 2019, I believe we started offering the ability to combine a foreground and a background pattern. The foreground is the the pattern that display at the top, and these are the different options. And the pattern, the background, it's what lies behind it. An example, if you want to, for example, represent, I don't know, some offices do this, an existing CMU wall. And so you could choose, okay, the CMU wall is represented like this, but to represent that it's existing, I'm going to do a solid color gray. Color gray, and then this is these are two hatches that are overlapping in the surface represent. Oh, the surface. Oh, actually, this should be the cut pattern, not the surface pattern. Maybe this is a model one, and it looks like a block. This is a surface pattern, and then this is the cut pattern. But for this particular example, for the Mila house, the pine material doesn't need to have any pattern. So I'm gonna actually take it, put it to no pattern on both entities. No pattern and no pattern. It's up to you, and you may also choose to display. The thing is that when we're creating these layers of stud, it's not like Revit is gonna build the stud profile at a specific distance. All we're saying is that this layer configuration is gonna hold studs, and it's gonna look like this, but it's just a schematic representation. It's not gonna place the stud for you. It's just holding the layer thickness that is needed to make the partition geometrically correct. Okay, so we have these, we have the appearance, the physical and the thermal as needed. And then this is ready to go. Hit okay. All right, that's how we create a new material from scratch. So let's switch the view here to floor plan. This is the floor plan, and you can see that Revit is actually telling you how the partition is going to look like. I'm going to disable the wrap property. Remember last time I talked to you what wrap was? And when you enable wrap, the wrapping rules that are displayed at the bottom of this panel, these at insert and ends, those kick in. I'm not going to use those here. I'm going to add an extra layer. And so we have on the exterior side, we have a wood vertical. Then we have a structure wood stud layer that is 8 inches. And I need a finish in the interior that it's plywood sheeting. So to add a new layer, pick the lowermost layer, which is the row number 4, and then insert. Notice that when you insert a layer, it's always by default going to place it above the selected row. And I'm going to move it down. So you use these up and down buttons to move the layers in this tabular display. And I put it away from the core because this plywood is serving a finish function. And as such, I'm going to pick finish 2 bracket number 5. Notice how I pick a different bracket number because they're going to have 2 dissimilar finishes. If they have the same finish, maybe I will pick the same number. And remember the bracket, it's the priority number, and it's what Revit used to make these automatic connections of layers at corner conditions. All right, so we have layer number 5 is a finish. The material, let's pick the plywood. So click the 3 little dots in the material cell. which opens the material library again. I believe there's a plywood material here. You can search it on the search cell. Just search for ply. And there should be a material called plywood sheeting. Here it is. It's a good idea to review how it looks like. And this is how it's going to render. These are the physical and thermal properties. You can enable the use render appearance to make sure that it looks closely to the JPEG in a shaded view. And that's it. Just
So
select it. Say again.
what is the appearance like of, can you please go to the appearance asset? I see a different,
This?
yes, what,
Yeah.
it's plywood new. Okay, sorry. Okay.
Yeah, these are the assets. And these assets were brought from whoever built this material. It brought it from the
Okay.
material assets.
Sorry, I was clicking the wrong material. That's why I was seeing something different. No.
Okay, it's plywood sheeting. Yeah, and if you don't have the material, you have the opportunity to build it yourself, but you have to pick the right assets for the appearance, physical, and thermal.
Cesar, did you get the appearance to the graphics to match the appearance? I have a different color on mine.
So in the graphic, click this checkbox that says use.
Got it. Yeah, sorry.
Yeah. And then this RGB value is going to be the same RGB value that you get in the appearance tab.
Yeah.
Yeah. So then you hit OK here. And I got the finish. And then the thickness should be 1 inch. You can just type 1 inch or just type 0.1. And I'm going to disable the wrapping checkbox. I do want to enable the stud layer as the structural material. The only thing that this does is to enable the analytical plane of the partition for analytical purposes. And this is how the partition looks in floor plan. It's brand new. You can swap it to section. You can zoom in this section and do more of it. Now, the exterior Mila house partition, look at these properties right here. This is a summary of what the total thickness of the partition is, what is the R value, and what is the thermal mass. That's something that we care about. Another thing that I want to show you is that what's going to happen is that these partitions are going to be placed. The core of the core is going to be aligned with the edge of the slab. So if I sketch that here, this is going to be my slab on the ground. And then I want to protect this this joint by extending this layer down, maybe by 4 inches. And that's something you can do here by unlocking the layers. So let me show you how that, oops. I have to redo this again because I clicked cancel. Ugh. Where's my project browser? I'm going to do this very quickly. Mila house. I'm praying what I told you not to do. I'm just going to add a new layer. I'm going to move it down. And I'm going to hit finish 5. This is going to be the plywood sheeting. And 1 inch. Disable, switch this to floor plan. And this is going to be the stud. Yeah, I have to do the whole thing again. Duplicate with share assets. Would yeah. Appearance, physical assets. Would. I'm going to ignore the Telma properties for now. All right, so I am okay. I have cut up. This is the plywood sheeting, the wood stud layer, the wood vertical. I want to just review the wood vertical very quickly. The wood vertical, it's made of plank. So this is a representation of planks. Let me show you how to get there so that you, I'm going to save it. Okay, this time again. Okay, I saved that. I want you guys to look at the properties of the patterns, because I didn't talk about that. So double click the exterior Mila house partition, open the structure, then open the wood vertical material. And let's talk about a little bit more about patterns. So patterns in Revit comes in two types. You have drafting patterns and model patterns. Drafting patterns are generic representation of typical materials where scale is not critical. In other words, these materials are a generic representation of how we typically in industry standards represent a material. For example, concrete or sand, or sometimes like steel or CMU. Drafting patterns are not scaled across view scales, meaning if you have a detail that is 1/8 of an inch or 1/4 of an inch or 1=1, the representation of sand, concrete, and wood are always going to be looking the same. Like the drafting patterns are consistent across the different scales. They don't change. And that's why they're called drafting. They're just a generic representation of materials. And these are ways that we use to generically represent wood. These are ways in which we generically represent concrete and sand and deep wood. Drafting patterns, when we create a new pattern from scratch, we have to decide whether it's a drafting pattern or a model pattern. A model pattern, it's module specific. So this is going to, if you notice the name of a model pattern, it describes the modular size. And so these patterns actually the proportion will change according to the scale because it's preserving the distances. And so if you're, for example, drafting an interior restroom at 1/4 of an inch, then the grid is going to be denser than if you would do it. It will be less dense if you do it if you see it at 1/8 of an inch or 1/16 of an inch. Drafting keep a consistent appearance for generic representation of materials. Model keep a consistent module and the grid will be preserved. The distance will be adjusted according to the scale. And so this particular material has planks. This material is a model material because the plank has a specific size. And so to access the properties of this, if you hit the little pencil here, it will tell you that this pattern is follow a basic parallel line representation 4 inches apart. If you want a representation of planks every 6 inches, then you can duplicate this using the duplicate button here. For example, I'm going to duplicate this. I'm going to call this plank 6 inches. And it's a parallel line at 0 degrees, 6 inches apart. And I have created a new pattern, model pattern based on an existing.
Would you want to make that 90 degrees so it goes up, down?
Oh, you're right. My bad. Yes. I want to do this 90 degrees. 0 degrees is
Yeah.
east west. Yeah.
Yeah.
There you go. So out of the box, you can create you can use parallel line and cross hatches. But if you need something more complex, for example, brick of a certain size of a pattern or some kind of a special floor tiling, then you can import AutoCAD hatches. So you hit here on custom, and then you browse your PAT file. PAT files are the extension for the AutoCAD patterns. And you can find a lot of them online. So I have an exercise about patterns later in the class. So I'm not going to do it right now, but that's how you can create custom patterns. For example, if you look at the shake 6 inches, this was definitely done via an import. You see how it says custom. So these PAT files, which is a text file that describe segment length, distances, angles, and spaces. That's what a path file can be. That's how a pattern file can be brought into Revit.
Side note, is there a way to bring in Bluebeam hatches into Revit? Just,
Good question.
just something that I've been trying to figure out. But just a question.
I don't know. I used to be very good at Bluebeam, and I can't recall if the pattern definition in Bluebeam are anything could be exportable.
I see.
I never did that exercise. I don't think so.
Yeah.
But that's my guess. I'll have to dig deeper on that. Okay, so this is how you create new patterns, fill patterns, and this lat. Oh, this is not what I want for the vertical one. I want planks, the original planks that are 4 inches apart, and then hit OK. So that was my side note about material patterns. Okay, so this is ready to. Oh, I wanted to show you guys that, you know, these partition. This is the exterior. Yeah, 1.5 exterior, and this is the interior side, and that I wanted to. This is the location line of the partition is going to be the exterior core. This is the plane that anchors the partition to the ground. And the other thing is that I wanted to protect the edge of the floor by extending one of the layers. And so you can unlock layers and enable the user to give them extension. And the way you do that, I'm going to pick the exterior-most layer here. Make sure your panel is in the section view. This is not going to work if you have a floor plan. Make sure you are on a section view. And you can zoom in towards the lower part of it. And then you go to modify here. It says modify vertical structure. And then hit the outermost boundary. I don't know if you can notice, but when you highlight, when you enable the modify, you have an ability to select the outer boundary of a layer. And you see that little lock, you unlock it. And when you unlock it, then in the project, you can individually push that layer down. And that's going to be a new property in the partition property build. So, I make sure you have this on the section view.
Yeah.
Then hit the modify button here.
Yeah.
And then move your mouse and pre-highlight the bottom side of the wood vertical, the plank layer, and unlock.
Where do you say, where's unlock?
The modify, sorry. The modify button.
Yeah, no, I'm there. I just can't unlock.
Oh, and then with the mouse, just click on top of it.
Okay, the graph, so that's an open lock. I see. All right, thanks.
Modify, and then just click on the panel and unlock the layer. And so the nice thing of this is then, my floor could be like sitting here. And then this layer, I can say, okay, I want just the outermost layer of this partition to go 6 inches down from the level. And that's going to be an instance property. There are other things you can do.
Not doing anything now, but unlocking it so that you can do something in the future.
Correct. That's what we're going to do next.
Okay.
Yeah. I cannot pull it down here in the panel, but I'll do it in the project.
Okay. Thanks.
All right. So my partition is ready. I hit OK. Hit OK. And we're ready to place it. So I'm going to switch to level 1 because that's probably the easiest part to place partition. And I know that this partition needs to go 16 feet above the ground. This is a graphic reference for me. And we are going to trace it. I'm going to switch the display view to wireframe. When I do this wireframe, it enables me to see through the existing floor, and I can see the image that I'm using to trace the house. And so I'm going to place the new partition. And it's very simple. We're just going to trace the exterior. We're going to do it clockwise. So go to wall. Then in the property windows, select the Mila house, the exterior Mila house partition.
Do you want to select the location line too? Like if it's connecting to the outside or inside or center point?
Yeah, the location line must be the finished core exterior. So I'm aligning the face of the stud with the edge of the floor. The height is going to go from the ground level, which is level 1. I am on level 1. It's going to extend all the way to the roof level, which is 16 foot above the ground level. The location line is core face. It's going to build a chain of elements, and I'm going to build it clockwise. So that means I'm going to go in this direction, and all I need to do is snap to the intersections of the grids that are in place. So this is this goes here. And notice how the outer layer of the stud, it's it's a way, like I'm placing this partition using the core in exterior. All you need to do is trace it over. Just go to intersection, to grid intersection, to grid intersection. Revit also notice it take care of the corner conditions. You don't have to fillet them manually. The height of these partitions is 16 feet. The core, the exterior core of the partition, it's aligned to the edge of the slab. Because the next exercise is to lower the that layer by 4 inches. Okay, so I just went clockwise. This is what I did in 3D. There it goes.
Can I want to look at
This is the partitions. The next thing I want to do is to, so let me ask you, do you guys got this? You want me to do it again? Anybody behind?
Could you do that wall building one more time? If you
Okay.
don't mind, really quickly.
Okay, I'm going to, by the way, if you want to select a chain of elements, just hover over, hit tab, and Revit select everything that is connected. Hover over, hit tab, and then I delete. We'll do it again. Level 1, wall. In the property drop-down menu, select the exterior Mila house partition we just finished creating. Check the parameters, height. The height of the partition is associated with the roof level. The location line is core face exterior, and we're going to place it clockwise. So I'm going to start from the intersection of A, B, and 1. Make sure you switch this to wireframe to be able to display the image. I'm going to start from this intersection, and all I'm doing is tracing over the house. So in the
Quick-
yeah.
Quick question, Caesar, will you be, so the wall we've just built, it doesn't have insulation in it.
No, it does not. And insulation is not something you can embed as part of the partitions,
Mhm.
but you can, and we're going to do this, good question. One thing we can do, and I'll show you now, is that you can add insulation representation as a view specific element. So if you go to the annotate tab,
Okay. I've used that in details, but if you want to show it the way it's shown like this in plan, so we'll have to manually draw it.
yeah, unfortunately.
Oh, okay. Okay.
Yeah, but for the rest of the people, the insulation tool allow me to create this type of insulation representation for details. Yes, you're right, for details, and you can change the width and the insulation ratio, which is how dense the insulation needs to be. So I'm going to put it 3.5, and that's if we want to add this to the floor plan, then we'll have to add it manually all across. You may want to try it with a couple of walls so you get familiar. So you go to annotate tab, insulation, and then go Revit automatically snap to the center of the lines. The insulation width is 8 inches, and the insulation bulge ratio is 3.5. But yeah, unfortunately, it's a manual process. It doesn't come with a wall.
Mhm.
But I'm just gonna add a few of them. I don't think I'll have time for all of us to do this. But if you want to do it as a homework, just add the insulation to all of them. Okay, any questions? All right, the other thing I want to show you is how you can unlock the, how you can add these extensions. So when you select this wall type, notice now that I have these, in the lower side, I have now two different grips. One is for the exterior layer and another one is for the base of the wall. So if I want to like graphically lower these, you can just select it and pull it down. Now this is not control. This partition. It's the distance is a little random. So when you unlock layers in the wall definition, you will enable this base extension distance parameter. This wasn't there before. This is added when a user unlocks layers. And here you be very precise. You can say, oh, all I wanted to extend it is minus 4 inches. And then hit apply. And that's the overlap. Now you can do it for all of them. You hover over one of the walls, hit the tab key to select the entire chain of walls. And then in the base extension distance, just type minus 4 inch, hit apply. And then the exteriormost layer will be now like overlapping the edge of the wall. That makes sense?
How did you do it all at once?
Yeah, hover, pre-highlight one of the walls and hit the tab key. And then mouse click.
Got it. Okay.
Hover over one, hit tab key, mouse click, and then base extension distance -4. And that extension distance only applied to the unlock layers in the wall definitions.
Something that's pretty cool with what you're showing and that I've had the opportunity to do before is that you can actually split your wall into multiple layers vertically. So if you have like a 6 inch, 8 inch, 10 inch curve, you can put that on the bottom. So you can have as many different wall types stacked on top of each other as you want, which is pretty cool.
Yeah. When we talk about interiors, I'm going to show that ability. Because some of these walls may have a different finishes, and that's a way to maybe apply a different finish to the same face. Alternately, you can also do stacked walls.
Oh yeah, for sure. Just a simple stacked wall and then join it. Yeah. Okay, so we have a chain of walls here. Any question? And this was done completely from scratch. We created we started with the generic one. We added new layers. We assigned new materials. We created new materials from scratch. We built the exterior pattern. We unlocked the layer in a section definition. We applied the same distance to all of the walls. And so the next thing we're going to do is to slope it, slope the top. So in the sketches or in the 3D view that you see here, the geometry is very simple. It's just two bodies of geometry with the sloping tops, like
the center, the demise wall between these two bodies, it's at 16. And then there's also these walls are at 16, and then everything else is sloping down. So I'm gonna sketch it here. This wall here is 16 foot high, and so is this and that. And then the other ones, in the other ones, I have a roof that is sloping in this direction, and I have another one that is sloping in this direction. But the lines in red are at 16 foot high, and I believe these other walls, this one, these two, and these two, I think they are at 9'6". Yeah, 9'6". Okay, so how do I slope those things? The best thing is to go into the elevations. So I'm gonna or let's go to a 3D view. Open the 3D view, the full 3D view. All right, so this is the demise wall, this and this, that needs to measure 16 feet. And so I believe these and that, these two big one. And so this wall and this wall needs to measure 9'6". And so all I need to do is to change the top constraint. These two walls are not going to go to the roof level. They're going to be to the level M, the mezzanine. And you got that? I'm going to do it again. I'm in the 3D view, just open the 3D view. And I'm going to select these walls, and I'm going to do the 4 of them. These 4 walls that you see on the screen, those walls need to measure 9'6". They don't need to measure 9. So I'm going to change the top constraint. Instead of the roof level, it's going to be associated with level M. And then these other walls, this one, and this one, they're going to be sloping walls. But so before I move, were you guys able to do this? Change, select these walls, these 4 walls, and change the level from roof to M.
Yep.
All
Yes.
right. All right, so the next step is to slope these walls. And it's going to be a fairly simple process. I'm going to do it once if you want to watch, and then we're going to do it together. And then I'm going to let you finish the rest. So you select this wall, edit the profile to access the sketch lines. This is the original sketch line for the wall. You can switch to the back view if it make it easier. And then you grab this drag line and snap it below. Well, what you can do is delete the top is probably easier. Delete it, create a sketch line from this point to this point, and then clean the geometry using the trim extend, which is the equivalent of the fillet in AutoCAD. And this is changing the shape of the wall. Now you hit the green checkbox here, cancel, and there you go. All right, let's do it together. I'm going to undo this and let's do it together. Oops, not too much. All right, I'm in a 3D view. I'm on the looking like the north side, northeast corner. Select the wall that's going to slope, and then edit the profile. When you edit the profile, Revit give you access to the sketch lines that define the boundary of the wall. I snap to the back of the wall to work orthogonally. You can also do it in an elevation. I personally prefer to model in 3D, but it's up to you. Then I select the top sketch line and then delete it. And then I create a line from the 16-foot high point to the 9'6" point below. And again, the sketch lines to work need to be connected in a continuous loop. So then I use the trim stem to corner to connect these two lines and hit the green checkbox. And I have a sloping top. All right, so we need to repeat the process for this wall here, and then these shorter walls as well. Actually, these shorter walls need to be 16 foot as well. No. All right. Yeah, I think so. Okay, let's do the sloping of this wall again. And you know the process already. You select the wall, edit the profile, select delete the top, draw a line. If you do it in the front view, it's probably easier. A line from here to here. Hit the green checkbox. Clean the geometry. I have these sloping surfaces. I am realizing that I probably made a mistake with one of these walls, because I think what I want to do is to do a roof that looks like this. And so I picked the wrong wall. I think I need to reset. This wall needs to go to 16 level to go to the roof level, and I need to slope it down. That makes sense. I select this, then edit, make this shorter one, go to the level M. There you go. Then I select this wall, edit the profile, delete the top, switch to left, and then I build the line. Here to here. Yeah, this is what I'm aiming for. So again, my bad. I gave you the wrong instruction of changing this wall to a level M. It needed to be this small, this guy. So this guy is going to go to the level M, and then this guy remain at level, at the roof level. Select it, edit the profile. Edit the profile, delete the top. Switch to the right elevation to make it snap easier. And hit the green, clean the geometry. Yeah, so that's the profile of the house. So the sloping surfaces are, the sloping walls are the ones I am highlighting in blue. The shorter one are associated with level M. And then the tall ones are 16 foot high above floor. Those are associated with the roof level. Okay. Make sure you
Is there another way of doing this, like just modeling the roof and then letting the walls attach to the underside of the roof?
Yeah, there's other ways to do this.
Okay.
Like I could have created like a conceptual model and then create phase derived objects. Like I could create like a mass object and then derive it from the mass. Another one could be just create the roof and then extend the underside of the roof. I purposely chose this way so I can display to you how to edit profiles, which is like at the basic level, how you would do that. But
Okay.
you're right. Next class, we're going to talk about roofs, and we're going to build a roof of this thing. I can show you there how that works. Yeah, you are correct. Another thing that you might notice is that, I mean, these connections are not perfectly clean, right? Like when you look at this, connection, this corner connection, these step up, this step is going to display no matter what's the primary member. And so just for representation purposes, you may want to choose a meter connection for that corner. You know, and let me show you what I mean. When I go to level 1 and I look at these elevations, look how they crisp and clean they look. It's very simple, very crisp and clean. But I don't see that level of crisp lines if I leave the connections abutted. So for representation purposes, I may choose to make this connection meter instead of abutted. And so to do that, I think I showed you last time, you go to the Modify tab, then go to the wall joints, select one of the corners, and choose the meter one. And now when you choose that option, then the connection it
updates. Yeah.
It updates and it doesn't have that step up. So we can do it
But
again.
when you do build a roof, it will clean up that edge, the connection, right?
When you stand to the underside,
Yeah.
yeah, it will do. Yeah. Yes, but because I mean, there are different ways of doing this. I choose to do edit profiles. And when you edit the profile, I don't think I can extend to the underside of anything. So I'll have to reset it. I have to reset the profile and then extend it to the other side. But we can go over that in the next class. Okay, so I'm just gonna clean the corner of the opposite side here. Modify, tab, wall joints, meters. It's just graphically make it look better. And then the other thing I'm going to do is that this demise wall, this guy, it should be a single wall because I think structurally there's a big beam that runs like in that split the structure in half. So and there is a soffit in the interior that needs to be displayed in the interior. So what I'm going to do is delete one of these tall 16-foot partitions, and then I'm just going to connect them as a single one. So you trim these two walls like that. So it's a single wall. And then what I'll do is I'll edit. I need an opening here with a soffit. And so what I do is that these two walls needs to connect clean. So on a top view, I can just trim this back, click on the grip out, and then reconnect it to have a clean connection there. And then I'm going to have an opening here. And openings can be built in Revit using the opening tool. Openings, you'll find it under the architectural tab. And there's these are different ways of create openings. You can create openings by editing the profile, or you can create an opening object. So there's a wall opening, which is a rectangular thing. You select the wall you want to add, then you create this rectangle. And then this rectangle can be individually pulled in and out to create an opening representation in an existing wall. You could also edit the wall and add the wall, but the nice thing of there are pros and cons, to create openings. One way of creating openings is you select this, edit the profile, and create a rectangle inside that, and that creates an opening for you. But this remains associated with the profile of a wall. So if you need to change the opening, you have to edit the wall. In the other method, I just showed you, this wall opening is an individual entity, and it's a void intersected with a wall, and then it can be manipulated individually to generate a space. And so to build soffits in walls, I like this method. Again, it's a preference. And this wall opening only snap. It only affects the wall. It doesn't like and then the other alternate also is that you create a window that has no geometry, and that can also act as an opening. All right, it's 7:07. I'm gonna stop the class here. The recording should be ready for you to watch. I saved my data sets in today's folder, so if you fall behind, you can always retrieve my file. Next class, we're gonna go over the interior layouts. So we are going to build the restrooms. I'm going to show you how to load components, put it in place. We're going to do the layout of the closet and the mechanical equipment. We're going to add finishes and interiors and then renderings. And the doors and the exterior openings as well. Okay, any question? Feel free to stay after class if you want me to look over your file, or if you have individual questions and you want to do one-on-one. Otherwise, I'll see you Wednesday. Have a great evening, guys.
Thank you.
Thanks, Caesar.
Thank
Thank you.
you.
Thank you.
Thank you. Good night.
Have a good night.
Bye.
Hey, Caesar, I have a question.
Yes.
How did you join those two walls again?
Join them in a mirror condition.
Across the grid line 3. Yeah.
Okay, so these wall used to be, these used to be two different walls, right?
Oh,
I
okay.
I deleted one.
I see. Okay. Okay.
I deleted and then I just hit the trim stand to corner to connect this
I
with
see.
that one.
Okay, that was a step I missed.
Yeah, and then this guy here, you see how it remains unattached? And so to fix this connection, all I did is the perpendicular wall, drag it out and then drag it in, and that forces the connection to happen again.
I see. Okay. And then when you did the opening in that wall, did you just edit profile?
No, there's a command, architecture, wall opening,
Okay, cool.
hit the wall, and then draw the rectangle inside the wall.
Awesome. Okay.
And then you can select the object and use these handles to get a control of what's the size of the opening is. But this
Got it.
opening is basically the size of the space. So I just
Awesome.
Revit, these handles snap to the existing faces. So you can just grab it and stretch it.
Okay, cool. Thank you so much.
All right.
I have a question. Can you
Yeah.
show how you did the miter at the corners?
Yes. I'm going to do it in this corner. So you go to the Modify tab, and then under the Geometry set of panels, there's the Wall Join tool.
Okay.
It's this icon with a little pencil on the corner. And then you, in the model, hit the corner condition at the lower base of the wall. You see that corner there. And then when you click, these options will be highlighted for you, and just change it to meter.
Oh, okay. Okay. Yeah, I didn't see that. Thank you.
And then you see now it changed to meter.
Oh, very good. Yeah, that's great. Thank you.
Okay.
Sorry, Caesar, I know you just explained this to David and I was about to sign off and I realized I had the same question.
Go for
And
it.
didn't quite catch it, but the wall that you made to make the interior wall by deleting one of the exteriors and extending it, what was that extension to end command piece that you had mentioned?
It's the fillet. So it appears when you select the wall. It's this trim extend.
Oh,
It's this button here. So let me redo again. This is how it was. And what I did is I'm in the Modify tab. I hit the Trim Extend Corner command. It's next to this rotate icon. And then pick the wall you want to extend and pick it where you want it to extend it to. And that connects it.
got it. Okay, thank you.
Did that work?
Do it, I was watching you, so I'll try right now.
Okay. And I see David. David, do you have a question?
No, I'm good. Thanks a lot, Caesar. I'm going to sign off.
Okay.
All right. Have a good night.
Have a good night, guys.
Yay, yep, it worked. Thank you.
Okay.
Okay,
Bye,
good
Nikki.
night. Bye.